Hi there, this is our first ever chem video lesson. So this is Unit A, which covers matter and change. And today's lesson is what is chemistry and what is matter. So in this video, we're going to cover a definition of chemistry, the definition of matter, bases of matter, and some of the different areas in chemistry, most of which we will cover this year. So if you ask somebody what chemistry is, they might say, oh, it's complicated formulas, it's equations, it's the periodic table. Most people honestly think the periodic table is all there is to chemistry. Yes, everything is made up of the things on the periodic table, but it's such a tiny little aspect of everything. People might also say, experiments, chemicals, chemical reactions. And again, you're not wrong, but there's just so much more that goes on. So if you were to look up the definition of chemistry in your textbook, online, literally anywhere, it would tell you, chemistry is the scientific discipline involved with elements and compounds composed of atoms, molecules, and ions, their composition, structure, properties, behavior, and the changes they undergo during a reaction with other substances. Now, that's a very long definition. Doesn't make much sense. So the what you need to know definition, or the WYNTK, what you need to know, chemistry is the study of matter. Now, if you notice, these words are a different color. So the note sheet that's posted has blank spots. So these different colored words go on those blank spaces. Okay, so now we know that chemistry is matter. But what is matter? And the easy answer is everything. But again, that's not super helpful trying to define what chemistry is. So matter is anything that takes up space and has mass. So taking up space, that is another word for volume, and taking up space and has mass. So if you were to put it on a scale, no matter how tiny, if it's not 0.000 repeating, it has some sort of mass. So therefore, it is matter. So here's a picture of a llama and an alpaca. I don't know which one is which, so if you know, great job. But if we ask ourselves, is this matter? Hopefully you all say, yes, both the llama and the alpaca are matter. They take up space and they have mass. And they're pretty fluffy. Okay, so this watermelon monster salad thing, is this matter? What about this peach? That is matter. The watermelon is matter. Is that a grape? That grape is matter. The table is matter. The plate is matter. The stuff in the background is matter. The air in this picture is matter. So everything is matter. This pet rock, the stuff around it, the paper, the box, is this matter? Is everything in this picture matter? Yes. This coffee cup, the beans, the sack, the floor, the spoon, everything, the steam, the actual coffee itself, everything in this picture, is it matter? The answer is yes. And lastly, we have this picture of, the clouds, the sky, balloons, air in the balloons. Everything in this picture, is this matter? Yes, it is. Now, question I have for you. Are you matter? So you might want to ask yourself, well, self, do you take up space? Yes, you do. And do you have mass? You also do. So spoiler alert, you are matter and you do matter. So this is your Motivational Monday on whatever day you are watching this on. And whenever, you're feeling kind of down, just think of chem and that you are matter and you do matter. Okay. So moving on, diving a little bit deeper, we have the three phases of matter. So solids, liquids, and gases. So solids, in particular, have a definite shape and a definite volume. So what that means is that the shape and volume does not change. So here in this picture we have a cube. So let's pretend it's a cube of sugar. If you put that cube of sugar in your hand, if you put that cube of sugar on your bed, on the floor, throw it to your friend, the volume still stays the same. The shape is still cube-shaped. That's not changing. If you think about any kind of solid, your phone, no matter who's holding it, where you put it, if it's being thrown in the air, if it fell in water, it's still the same shape and the volume is still the same. So the particles in a solid are very, very, very tightly packed and very close together, and they only really have enough room to vibrate. Again, examples of solids, headphones, ice, shoes, phones, the list can go on and on and on. Okay, so liquids. Liquids have a definite volume and an indefinite shape. So what that means is that the volume or the amount of liquid isn't going to change, but depending on the container you put it in, the shape will change. So here we have, in this lovely box, the liquid completely fills up the bottom of that box. But if our box was shaped like this, the water would fill up this space. Now it's a slightly different shape. If we put the water in a bowl, it would be a different shape. But let's just say that we have, 20 milliliters of water here. If we pour it in there, it's still 20 milliliters, but now it's a different shape. So the particles in a liquid have enough room to kind of slide past each other. So that's what gives it its indefinite shape. They are more spread apart than solids are. And examples of liquids, again, the list can go on and on, but water, coffee, and tea. Moving on to gases. Gases have indefinite volume and indefinite shape. And that means if you change the container a gas is in, the shape and the volume will change. So this picture shows the same size box as, gas and solid. But now the gas takes up the entire space. Now this is going to be a closed box because you have all of the sides closed. But if this, top was to open, all these gas particles would go everywhere and take up whatever size they're in. So gases completely fill up any container they are in. So if you had, all the air in your room right now, you could actually compress it or squeeze it into a very small, let's say, tank of air. So if you ever gone scuba diving or had, air tanks, that's a bunch of air, but it's compressed or squeezed to fit a smaller container. Because it's easier to carry something the size of a water bottle than it is to carry something the size of the room. So you have that. In a gas, the particles are moving very, 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 very quickly, and they're constantly bouncing off of each other. Gas molecules are crazy. And when we get to gases, we're going to spend a lot of time studying these crazy, fast-moving, high-energetic particles. And an example, air. So, yes, there is a fourth phase, and I'm only going to mention it now, and then we'll never talk about it again. But the last one is plasma. So plasma is kind of the step after gases. And this is when negative electrons. So you have an atom, and you have positive proton. You have a neutron. And we're going to get into this in more detail. And that together makes a nucleus of the atom. But then you also have these negative electrons that circle around the nucleus. So here are negative electrons. So when plasma happens, or is formed, these electrons are stripped away, so they're gone, leaving only this positive charged atom behind. So we call atoms with a charge ions. And again, when we get to atomic history and atomic structure, we will go into that in much more detail. So just to kind of give you guys an overview of this year, so we're going to cover the atom, periodic table, bonding, that's a long unit, we split it up into two, moles, stoichiometry, gases, solutions, thermochem, kinetics and equilibrium, acids, bases, and salts, redox, organic, and nuclear chemistry. So by the end of the year, we'll have touched over all of this and how all of this actually affects your life. And through that, we'll go into some of these real-life examples, like scuba diving, ocean acidification. So scuba diving is our gas unit. Ocean acidification is our acid-base unit. Batteries is our redox unit. Fireworks we can go over when we go over periodic table. Glow sticks we go over when we go over periodic table. Cooking, magic tricks, even making rock candy. All these things are examples of chemistry in your life. Now that's it for this video. Next time we will cover classifications of matter, the differences between elements, mixtures, and compounds, and the different types of mixtures. That's it. Bye.